Hello, this is Mrs. Ross, and we'll be working on Algebra 1R, Homework 9-3. We're going to go over the odds, and let's start with number 1. The number of graduates at a high school has increased by a factor of 1.055 every year since 2001. In 2001, 110 students graduated. The function n parentheses t equals 110 times 1.055 to the t models the number of students n expected to graduate t years after 2001. How many students will graduate in 2012? Okay, so let's go ahead and highlight and take a look at some of the important information we want on there. So on our, we have this is our formula that we'll be working with, and then we're going to go ahead and alter that and change that for the information that gave us. We know that 2012 was 11 years ago, according from 2001 that they had earlier. So that's 11 years ago. Oh my goodness, messy writing. Okay, 11 years ago. So 11 years difference. So we're going to go ahead and write out, we can write our original. If it makes you feel comfortable, the entity equals 110 times 1.055 to the t. Okay? Then we're going to go ahead and plug in the information we do have. So the end of the t equals 110 times 1.055 to the 11th. That's our, because it's 11 years now that they've done this. Okay, so how many students will graduate in 2012? You go ahead and plug that in your calculator. You just take 110 times parentheses 1.055 and parentheses to the caret 11, and you will get 198.2301. Well, we want to go ahead and round that up. They want to know how many students approximately will graduate in 2012. 198. We won't round up. It's not that high. So 198. Oh, and we should probably write students. 198 students. Okay. That's your answer. Let's go to number 3. Daniel deposited $500 into a savings account, and after 8 years, his investment was worth $807.07. An equation A equals D times 1.005 12t represents the value of his investment A after T years with an initial deposit of D dollars. So I'm going to go ahead and write out that original formula. You can you can highlight it and just make sure you know it. A equals D times 1.005 in parentheses 12, and then we have a T. So they're going to give us some information that we're going to go ahead and plug in. What they did to figure this out was they went and plugged in A equals 500 times 1.005 times 12. The T is now an 8. So then when you go ahead and plug that through, it's going to give you the $807.07. So you went ahead and you do 12 times 8, which is 96. So it's 500 times 1.005 to the 96th power. And when you put that in, it gives you 807. And that's how they got that. Oops, that's how they got that one. So we're going to use that same formula and plug in different information. They told us that they had deposited $500. This time they're asking, how much would you get if you deposited $1,000? So we're going to reuse that same formula and go ahead and take A equals D times 1.005, 12 times 8. We're sticking with that. So our new formula is going to be A equals, our D is no longer 500, it's now changed to 1,000. 1,000 times the 1.005 to the 96th power, because that's the 12 times the 8 over there, to the 96th power. And that's going to then give you, if you put that in your calculator, it's $1,614.14. Okay. B, what would the value of Daniel's investment be if he had deposited $250? So this time we're going to use 250 instead of the 1,000. So we're going to go ahead and use A equals 250 times 1.005 and parentheses, and it's the 12 times the 8, which is 90 to the 96th power. Okay, and we're going to put that in your calculator. 250 parentheses times 1.005 and parentheses caret 96, and you're going to head and get, your calculator will read 403.5356. We'll go ahead and round that. So it will be $403.54. So for C, we're going to interpret D times the 1.005 12t to explain how the amount of the original deposit affects the value of Daniel's investment. Well, as we know, if we put in more money, the more profit we make. So we've put in here 250, we made $403. If you put in 1,000, you make $1,614. If you put in 500, you made 807. So the greater the initial investment, the more profit you make. The more profit you make. Okay. Question 4, you're going to take a look at the table, and does it represent a linear or exponential function on each of them? So you take a look, for example, in A, and you go, oh, my y, how much is it changing? It's increasing by 2. If we're just increasing and we're adding, that means it's a linear. And that's we added 2 for each, and it increases by 2 each time. Now take a look at B. Gee, 6 and 12, it increases by 6 there. And if I add 6, that doesn't work. So it's 6 times 2 is 12. 12 times 2 is 24. So it is exponentially increasing. So it's an exponential. So it's multiplication. So when it's multiplication, remember that's exponential. So it's exponential. And it's multiplied by 2. Multiplied by 2. For C and D, you do the same. You look and see. Is it adding? Is it multiplying? Or is it subtracting? Is it reducing? And if it's reducing, that would be depending. If it's division, it would be, if it was dividing by, it would be exponential. If it is subtracting, it would be linear. Okay? Let's move on to question 5. Question 5. The graph represents the number y of visitors to a new art gallery after X months. So we have our graph. It's go ahead and stating. So we're going to write an exponential function that represents this situation. So we have on our table, we can note on here that we have an increase. We have a 40, a 60, and 90, and 135, and our X is 0, 1, 2, 3. So our X started at 0. And at 0, it was already at 40. That's how many visitors right away, 40 visitors. Then after 1 month, we had 60 visitors. After 2 months, we had 90. After 3 months, we had 135. So we have to write an exponential function that represents this situation. So when we're looking, we're going to look and say, okay, y equals, and how would we write this? So the starting point is 40. So we start with 40. And we have an exponential increase of 1.5. So we just did that with our table. We were noticing if there were increases in things. So it's times 1.5 there. 60 times 1.5 should give you 90. And you just keep going through. So it's an increase of times 1.5. So we go ahead and put that in there, times 1.5. And the x is after how many months, depending on how many months. So in B, we're going to approximate the number of visitors after 6 months. So we have after 6 months, which is where our x is going to be. So that's our x that we're going to be entering in that 6. So we have our y equals, let me just do this. Y equals 40. Come on. Why is this not writing? Okay, is that going to do it? I hope that's going to do it. Killing me. Come on. Okay, now we should be good. Here we go. If I don't shift everything all over. Y equals 40 times 1.5 to the 6th. That we're talking about after 6 months. So when you go ahead and put that in your calculator, you will get 455.625. We have to round that. It's asking us how many, approximately the number of visitors after 6 months. Approximate the number of visitors after 6 months. So I'm going to round up, and that'll be about 456 visitors. Okay, let's go on to 7. Write an exponential function that passes through the points 0, 3, and 1, 6. So 0, 3, and 1, 6, which we show is an exponential change of 2. Okay, what is the domain and range of the function? So if we note that it's an exponential change there, we have, I'm sorry, a change of 3 times 2 gives you 6. That's what we're noticing there. So what's the times 2? X2 times 2. So if we were to write that out, it's going to be y equals, and so we know our normal is 3, and then it's exponential 2 to the x. That's how we write it, how we change there. Okay, number 9. Write an exponential function that passes through. Write an exponential function that passes through the points 0, 10, and 1, 5. So we're going to take a look at our y and see what is that change. It's a change of 1/2. That's so tiny. It's a change of 1/2. So that is going to go ahead, and that does decrease, but we have our y equals 10. So that was our starting point of 0, 10, and it went down, so 10 times the 1/2 to the x. Okay, that concludes the homework. Have a nice evening.